91. At this page, we're going to practice using benchmarks or rounding numbers or so in order to estimate and solve problems. What I mean by that is the following. Let's pretend that you have, for example, the number, I ask you at what is 46 plus, let's say 32. Okay, what is 46 plus 42? You might try to do it the traditional way where you add 6 plus 2 and like this 6 plus 2, and then you try to add 4 plus 3 and you can get the exact answer. But if you're in a rush and you just kind of want to know a ballpark or an estimate of what it is, simply round. You know, 46 is close to 50, right? So that you can say this is 50 and 32 is close to 30. So 50 plus 30 is 80, and you can just say it's about 80, okay? When the actual answer would be 78, it looks like to me. Yeah, 78. So that's pretty close. That's pretty close. 80, 78, you know. 80 would be the safe bet. You know, it's better to overestimate it to underestimate. So we're going to go ahead and work with that, but instead of working with round numbers, we're going to work with fractions, estimating when you add fractions together. Okay, so let's look at number 1, 2, 3, and go from there. Okay, so let's zoom in. Number 1, and we are being asked the following. Let me just choose a good pen. Here we go. We're being asked to place these benchmarks 0, half, 1, 1.5, and 2 along this line, right? Well, I'll start with my lowest and highest. I know that 0 is my lowest and 2 is my highest. And right in the middle, I will have 1, right? There's my 1 right there. Okay, this is 1. So I need to place a half. So a half would go there, and 1.5 would go there. Done. Okay, continuing on. Okay, again, we're adding fractions over here. We are told that Samuel ran 1/5 a mile. 1/5 of a mile, which is 1/5 is 20% of a mile in the morning, and half a mile in the afternoon. Half a mile is 50%. So 20% plus 50%, that would be 70%. How much of a mile did he run? 70%. Did he only run half a mile? Well, 70% is about almost, yeah, it's just over 2/3. Did he run a mile? Or did he run about 1.5 miles? Well, 70%, okay, is it closer to half or is it closer to a mile? 75% would be the half mark between these two, right? 75%, which is 3/4. But it's closer to this one than to this one. So yeah, so he only ran about half a mile. Okay, he ran half a mile, but then he only ran 1/5. Not enough to count it as 3/4 of a mile. Okay, now for question 3, we're still expected to add. A recipe for bread calls for 1 cup of flour, a whole cup, okay? So that's 1/1. If Ryan has half a cup of white flour and 3/4 cup of whole wheat flour, about how much flour would he have left after he makes the bread dough? So he has half here, which is half, remember boys and girls, is 50%, right? And 3/4 cup over here is 75%. Wow, it looks to me like if we add 50 plus 75, we're going to have 125%. We have an additional 25%, right? So how much flour will he have left after? He only needs 1 cup of flour. Okay, how much will he have? Will he have about 1 cup? Will he have about more than 1 cup? Will he have less than half a cup? Now 25%. What do you think it is? You go ahead and choose your answer. And finally, question 4. Simone has 3/4 cup of whole milk. 3/4 cup. Again, 75% as we set up here. 3/4 cup, 3/4 cup. 75% of a cup of whole milk. And 1/8 of a cup. Everybody knows, and you've learned that 1/8 is 12.5%, right? So 75% plus 12.5%. So 3/4 cup plus 1/8 of a cup of milk. About how much milk does she have? Okay, does she have about half a cup? About a cup, or about 1.5? Okay, well, this looks to be pretty close to a whole, right? Almost very close to 100%. Go ahead and choose your answer. Next page. So as you notice so far, what we've been doing is simply just adding fractions, okay? But we're not really writing them out and finding a common denominator and trying to add them so we can get the exact answer. We're just simply taking that fraction, identifying it as a percent, and adding it. Adding it in our heads, getting an estimate so that we can find out if we're closer to half, 3/4, or a whole, or 1/3, or, okay? So the skill here to master is to make sure that you can convert a fraction into a percent. If you can do that, boys and girls, these questions will be very easy and you will have a lot of success on the test. So let's continue with number 5. We'll continue to convert a fraction or identify a fraction as a percent to help us, okay? Miss Lyons bought 1/3 pound of turkey, okay? 1/3 of a pound, 1 part of 3, so 33% of a pound. Half a pound of ham, so 50%, and 3/4 pound of salami, 75% of a pound, okay? So she never bought a full pound of anything. Here, 33%, 50%, and 75%. About how many pounds of meat did she purchase? Well, 1/3, let's estimate that about 30. With 75%, that's easily over 1 pound, right? If you take this one and you take this one, we have easily over 1 pound. And then another half pound. So is it going to be about half pound? No, we clearly have that just here. Is it about a pound? Well, just between this one and this one we have a pound, and we still have this one. So clearly it's about 1.5 pounds. Okay, you can totally see it there, boys and girls. Okay. Again, if you're having an issue identifying these values simply by estimating it into a percent, converting it into a percent, then just add them. Find a common denominator. Common denominator for 3, 2, and 4 would be 12. Make it all into 12. Convert the top as well. Whatever you did to the bottom, you do to the top. Add it, and you will have your answer. That's another safe way of doing it, but it takes a little longer. Okay? Question 6. Kevin has 1.5 yards of fabric. Okay, wow, 1.5 yards. So clearly he has 1 yard and a half. He will use 3/8. Remember that each 1/8 is 12.5, 2/8 is 25%, and 3/8 is 37.5%. Okay? I'll write it on there for you. 37.5%. Okay? He will use 3/8 of a yard to make a pillow. How much fabric will he have left? 37% will eat up about this half, won't it? Because this is 50%. So it'll eat up most of this, not all of it, most of the half. So is he going to only have about a half left, a whole left, or about 2 yards left? Well, 2 yards is more than this. Why would he have more? Okay, go ahead and choose your answer between the 3. I look forward to seeing those answers. And now, finally, let's answer question 7 together. Write your own fraction number story similar to the ones from problem 2 to 6. Okay, boys and girls, over here you're going to add fractions. It could be adding fractions of something that you and your friend ate together. Okay, one of you ate 1/8 of a pizza, the other one ate half a pizza. How much of the pizza did you eat together? That could be 1. Okay? And another one could be, for example, if you like running, or from the book Maniac McGee, the first day he ran half a mile, the second day he ran 1.5 miles, and the third day he finally ran, let's just say 2 full miles. How many miles did he run in all the 3 days? Okay, that could be another question. Go ahead and write your own similar story, number story. Okay, next page. Okay, let's take a look at question 8. A candle is 2.5 inches tall. Okay, 2.5 inches tall. When it burns, it goes down 5/8 of an inch an hour. So every hour we lose 5/8 of an inch. Okay, just over half an inch. Okay, about how much of the candle will be left after 3 hours? So 3 of these. So you go ahead and add this 3 times, 5/8 plus 5/8 plus 5/8, and then whatever you get from that, the sum of this, you subtract it from this. You can explain your answer. Okay, here's my explanation. About 1/2 inch will be left. Here's my answer. About 1/2 inch. Why do I say that? Well, in 3 hours, 5/8 per hour, 5/8 and 5/8. This is what's going to burn in the 3 hours, which equals 15/8, right? 5 plus 5 plus 5 is 15. 15/8, right? Or we could say 1 and 7/8. 1 whole, which is 8/8, 7/8. This is almost 2 inches. It's only missing 1 here to make it another 8/8, right? So 1 and almost another one. We could say that this is almost 2 inches will be used. So about ½ inch will be left because I started off with 2.5. So almost 2 inches will be burned. 1 and 7/8, boys and girls, is almost 2 inches because 1 inch would be 8/8, right? And another one would be another 8/8, right? 8/8 and 8/8. Well, I definitely have an 8/8 here, and I almost have another 8/8 there, right? So almost 2 inches will be used, and that only leaves me with the half there. Okay, I hope that makes sense to you. This is a key answer. Go ahead and put a star next to it. Let's try the next one. The perimeter of a triangle is 10 inches. Okay, the perimeter is the distance around the outside. The perimeter of a triangle is 10 inches. One side is 3 and 9/16 inches long. Another side, which 3 inches is almost just over half. Okay, 3 and almost and just over half. Another side is 4 and 5/8. Again, just over half inches long. About how long is the third side? Add this, and subtract it from this. You add this plus this and subtract whatever you get, the sum of these two, you subtract it from that, and that'll tell you what's left. Okay, 3 and 9/16. Like we got here, 3 and 9/16. 9/16 is almost a half. A half would be 8. 8 out of 16. That would be a half. But it's just over a half. 9/16. But 3 and 9/16 is close to 3.5. So this is almost 8/16, which is a half. 3.5. And 4 and 5/8. Well, the half here would be 4/8. We're only over by 1. So 4 and 5/8 is close to 4. Oops, that should be a half. Okay? 4.5. So 4 and 5/8 is close to 4.5 because this is almost 4/8. 4/8 would be a half. It's almost a half. So the sum of these two lengths is about 8. Think about it. 3.5 plus 4.5 is 8. The third side must be whatever 10 is minus 8. Like I said, add this and subtract it from this. So we did. We added this, and we got 8. And now we're subtracting it from 10. So 10 minus 8, which is about 2 inches. And that's how we get it. That's how we estimate our lengths. Okay, go ahead and copy this one down too as another key answer. So 8 and 9 are your key answers.